In this video, we're going to try to write the algorithm for the ISBN problem. The problem says that an ISBN number is a number. First of all, it has to be 13 digit, and also it has to have the following property. If we start with the first digit of the number, like this example here, if we multiply the first digit by 1, then get the second digit multiplied by 3, then get the third digit multiplied by 1 again, then get the fourth digit multiplied by 3, and continue adding these products. If the end product, which is the sum, in this case is 120, if the number is divisible by 10, then we know this is a valid ISBN number. Otherwise, it is not. So our algorithm has to get an input of a number and check to see if it passes this test. It has to either return true or false. For instance, in this case, this returns true because if you find the sum of first digit times 1 plus second digit times 3 plus third digit times 1 plus fourth digit times 3 and continue until the last one, which is 13th digit, the sum becomes 120 and it's divisible by 10. But if you look at this example, this is not 13 digit, so it returns false. In this case, if we find that sum is going to add up to a number which is not divisible by 10. So let's go ahead and write the algorithm. As usual, the first line of the algorithm is going to be start. So we are going to say start, and automatically I'm going to put an end to make sure that I don't forget the end part. So the input is, if we go, the input is called num. So the first thing I'm going to do is to see if num has 13 digits. So I'm going to say if length of num is not equal to 13, then automatically return false. And if. Now that we know it is 13 digit, I have to have a variable which keeps the sum of all these products. So I'm going to define that variable to be, let's say, sum, and I initialize it to 0. Now I'm going to set the index of the loop, let's call it position, to be equal to 1, the first character. Now I'm going to start my loop. So I'm going to say if position is less than or equal to 13, then I'm going to say and if. You may wonder, why did I put 13 here? Because I've already checked the length to be 13. If it is not 13, it is already out of the algorithm. So when it gets here, I know that the number of digits in num is 13. So that's why I put 13 here. I can also put length of num, but it's redundant if I do it. Now I'm going to check to see if position represents an even or odd number. So I'm going to say if remainder of position and 2 is equal to 0, then this means that the position represents an even number because it's divisible by 2. Remember, remainder returns the remainder of this division. If the position is an even number, meaning that it is either 2, 4, 6, 8. Then I have to multiply the digit by 3 and add it to sum. So I'm going to say sum is equal to sum plus 3 times digit or character of num at position. What about if the position is not even, it's odd? And I'm going to say else I'm going to do the same thing, but this time I multiply it by 1 times you may wonder why did I multiply by 1, because any number times 1 is the same number. Is that later on you will see why I did that. So this is going to update sum depending on the position of the digit. Obviously, as you know, after this I'm going to increment index by 1, and the last thing I'm going to do is that I'm going to jump back to 7. So I'm going to say go to 7. When I do all these, when I get out of the loop, I'm going to see if the remainder of division of sum by 10 is equal to 0. So I'm going to say if remainder of sum and 10 is equal to 0, then I'm going to return true. Otherwise, I'm going to return false. I know that it's not ISBN number. And the last thing is to put an if. And this is our algorithm for ISBN number. I mean, we can do a simple check here. Let's say 2-digit number. Let's say number is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. If this is the number, again, this is string, so we need the quotation marks. If this is passed, we know that the length is 13, because if you count how many digits is it, it is 13, so we're not going to return false. Then we set sum equal to 0, position equal to 1. So sum becomes 0 and position is equal to 1. Now, if I go through the loop here, the position is 1. So it is asking, what is position divided by 2, the remainder? The remainder is 1. It is not equal to 0, so it comes here and it says sum is equal to sum plus 1 times position. Position is 1, the digit is 1, so it's going to be 1 times 1 is 1, plus sum. Sum is 0, so sum becomes 1 times 1 is 1, plus 0 is 1. So sum becomes 1. Then it goes down and it's going to add to index, so incremented by 1 and go back to 7. So index was 1, position was 1 before, so this means this is incorrect. This has to be position. And this has to be also position. So position is going to be incremented by 1, so position becomes 2. So I'm going to type again position, and this time it becomes 2. And it goes back up. Now, because remainder of 2 divided by 2, position is 2, is 0, then it's going to do this sum. So it gets the digit, multiplies it by 3, and then adds it to sum. The second character is 2. 2 times 3 is 6, plus the previous sum is 1, so sum becomes 7. And you can see that it updates the value of the sum based on the character and the position. And at the end, it's going to check to see if it's divisible by 10. If it is, then returns true, otherwise return false.